I'm so glad you found your way here. Right now, without any effort on your part, your brain is actively releasing tension it has carried all day, preparing the conditions for something only stillness can provide. You'll discover what the neuroscience of nighttime silence actually does to a healing mind, and understand why internal peace is not something you create, but something your brain returns to. Welcome to Psychology for Sleep. Now, settle in. You're in your safe space, while your brain quietly shifts into its most restorative mode, the one it reserves for silence, darkness, and the absence of demand. Allow yourself this moment completely. We'll journey through 100 psychology facts about internal peace and neural healing, from the hidden network that activates only when the world goes quiet, to the chemistry of nighttime repair, to the moment your mind finally releases the weight it was never meant to carry forever. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Your brain has a hidden default network that activates the moment external demands fall silent. For most of the waking day, your brain operates in task-positive mode, processing the outer world, solving problems, responding to stimulation. But when that input stops, a separate network known as the default mode network, or DMN, quietly switches on. Identified through fMRI research at Washington University in the early 2000s, this network spans the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus. Rather than resting, it becomes highly active, beginning a process of inward sorting, reviewing emotional memories, constructing the narrative thread of the self. Stillness is not the absence of neural activity. It is the beginning of a different, deeper kind of work. The default mode network is sometimes called the brain's internal repair crew. Research published in Nature Reviews Neuroscience describes the DMN as the seat of self-referential processing, how you make sense of who you are, what happened today, and how you feel about it. When the external world keeps demanding your attention, this network is suppressed. It cannot do its work while you are being asked to do something else. Chronic overstimulation, news feeds, notifications, viennoise, keeps the DMN in perpetual partial suppression. The brain accumulates emotional debt. Night, when the world finally goes quiet, is when that debt begins to be repaid. The stillness you give yourself at bedtime is not passive. It is active biological permission. Total silence affects the brain differently than any other environment. A 2013 study found that 2 hours of silence per day prompted the generation of new cells in the hippocampus, the region associated with memory, learning, and emotional regulation. The effect was not replicated by calming music or environmental sounds, only by silence itself. Researchers proposed that the absence of auditory input removes a low-level processing load, freeing neural resources for regenerative activity. This was a mouse study, and human replication remains ongoing. But converging data from sleep and mindfulness research supports the same direction. The brain does something in silence that it cannot do otherwise. You are not wasting the night by lying quietly. You are using it precisely. The hours between 10 at night and 2 in the morning represent a neurological window that most people are only beginning to understand. Cortisol, the stress hormone governing alertness and physiological reactivity, drops to its lowest point in this window for most adults. When cortisol falls, the amygdala, the brain's threat detection center, softens its grip. Neural circuits involved in rumination become less reactive. This is not merely relaxation. It is a measurable shift in the brain's chemical environment, creating conditions where emotional processing can happen without the amplification that fear normally adds. The night does not just rest the brain. In this window, it changes what the brain is capable of feeling and resolving. Your brain produces its highest concentrations of brain-derived neurotrophic factor, known as BDNF. During sleep and deep stillness, BDNF is sometimes called fertilizer for the brain. It promotes the growth and survival of neurons, strengthens synaptic connections, and plays a central role in memory consolidation. Low BDNF levels are consistently found in individuals with depression, anxiety, and chronic stress. Sleep, and specifically the slow-wave stages, appear to be the primary trigger for peak BDNF release. This is why a single night of poor sleep can leave you emotionally fragile by morning, not from tiredness alone, but because the neurochemical scaffolding that maintains mood stability was not fully replenished. The night is a biological act of self-restoration. Internal peace has a measurable neurological signature. Researchers studying the neural correlates of peaceful mental states have used high-resolution EEG to observe brain activity in individuals who report feeling genuinely at peace, not merely calm, but inwardly settled and free of conflict. These states consistently show increased alpha-wave activity in the frontal and parietal regions, reduced amygdala reactivity, and synchronized theta activity in the hippocampus. This pattern does not appear during distraction or mild positive emotion, only during states characterized by self-acceptance and an absence of internal conflict. Peace is not just a feeling. It is a distinct and identifiable state of neural organization, and the brain appears to move toward it, naturally given sufficient stillness. The prefrontal cortex, responsible for judgment, self-regulation, and complex decision-making, undergoes a form of daily depletion that only rest can reverse. Each decision, each emotional regulation effort, each moment of resisting distraction draws from the same neural reservoir. By late evening, for most adults, this reservoir is measurably depleted, a phenomenon psychologists call decision fatigue. In this depleted state, the brain defaults to reactive, habit-driven behavior rather than thoughtful choice. Sleep, particularly the deep stages that dominate the first half of the night, restores prefrontal function. What feels like a moral or emotional failing in the evening is often simply an exhausted prefrontal cortex asking for rest. Your nervous system maintains a window of tolerance, the range within which you can process, experience, without becoming overwhelmed or shutting down. During the day, stress and cognitive demand can compress this window significantly, making you more reactive and less able to access nuanced emotional responses. Sleep, and the quietude surrounding it, expands this window back toward its natural range. Research by Dr. Dan Siegel at UCLA has linked good sleep quality to increased window of tolerance in clinical populations. People who sleep well show measurably more emotional flexibility, better impulse regulation, and a greater capacity to tolerate ambiguity without distress. The stillness of night is literally widening the space in which you can be yourself. The brain's glymphatic system, its waste clearance network, operates most actively during sleep, particularly during slow wave stages. This system, identified by researchers at the University of Rochester in 2012 and still a subject of active investigation, uses cerebrospinal fluid to flush metabolic waste products from the spaces between brain cells. The process appears to require brain cells to contract during deep sleep, allowing more fluid to flow through extracellular space. This is considered preliminary, but compelling evidence. With converging studies supporting the directional finding, the brain may be literally cleaning itself while you sleep. Internal peace, on this level, is also internal clarity. A mind quieted enough to be properly washed. So already, the neuroscience reveals that the stillness pulling at you tonight is not laziness. It is your brain issuing a biological invitation. The default mode network is asking for space to process. The glymphatic system is requesting depth of sleep. The prefrontal cortex is asking for restoration. Every system involved in your inner life, your sense of self, your emotional regulation, your capacity for clear thought, runs maintenance protocols that only nighttime quiet can fully enable. What the world calls winding down, your brain calls beginning the real work. You are not failing to stay awake. You are succeeding at something far more important. Alpha brainwaves, the neural frequency of relaxed, present moment awareness, increase measurably in environments of low sensory input. Alpha waves, cycling at 8 to 12 Hz, represent the bridge between active engagement and restorative rest. They are associated with reduced anxiety, increased creative thinking, improved emotional access, and a lower resting heart rate. During the day, beta waves typically dominate, fester, more reactive, locked into external tasks. As evening deepens and stimulation fades, the brain naturally begins shifting toward alpha. This shift is not automatic for everyone. Chronic stress and screen exposure can delay or suppress it, but the body's biological intention is clear. It is trying to slow down and move inward. Psychological research finds that unprocessed emotional experiences accumulate in the body and nervous system when not given adequate time for integration. The concept of emotional completion, the idea that emotions follow a biological arc from activation to resolution, is central to somatic psychology and supported by researchers including Antonio Damasio and Bessel van der Kolk. When the arc is interrupted, when you are always moving, always responding, emotions do not complete. They remain activated as chronic tension. or a persistent sense of something unfinished. The quiet of night creates the first real space, for many people, where emotional arcs can move toward completion. The heaviness at bedtime is often not tiredness alone. It is unfinished feeling, finally arriving at its moment to resolve. The insula, a cortical region deep within the brain, plays a central role in interoception, your awareness of internal bodily states. Heart rate, breathing, hunger, pain, and emotional tone are all processed through the insula before becoming conscious experience. Research has found that periods of quiet, inward-focused attention, particularly when practiced at night, increase insular activation and improve interoceptive accuracy. People with higher interoceptive accuracy report better emotional regulation and greater resilience under stress. Lying still in the dark, attending gently to your body's sensations, is not passive. It is directly training the neural pathways responsible for knowing how you actually feel. Night is when you finally have time to read the body's reports. Night activates the parasympathetic branch of the autonomic nervous system, the rest and digest system, which acts as a counterweight to the sympathetic fight-or-flight response. As light fades and activity decreases, heart rate variability increases, breathing deepens, and cellular repair processes accelerate. This shift is governed in part by the vagus nerve, the longest cranial nerve in the body, running from the brainstem through the heart, lungs, and gut, higher vagal tone. How readily the body shifts into this parasympathetic state is consistently associated with better emotional regulation, lower baseline anxiety, and faster recovery from stress. The night is not just the absence of day. It is a distinct biological environment with its own regulatory priorities. Internal peace, according to emerging psychological research, is not primarily a cognitive state. It is not achieved by thinking your way to it. It is a somatic state, arising from the body and propagating upward into conscious awareness. Studies using biofeedback training suggest that coherent heart rate patterns, smooth, rhythmic, sine wave-like cardiac cycles, appear to produce subjective states of inner calm. In many individuals, the physiological state comes first, and the feeling of peace follows. This is why physical stillness, lying down, breathing slowly, releasing muscle tension, is not merely symbolic preparation for sleep. It is generating the neurological and physiological conditions from which genuine peace tends to emerge. The body leads, the mind follows. The relationship between nighttime quiet and emotional memory consolidation is one of the most well-established findings in sleep science. During REM sleep, the hippocampus replays emotional memories and the amygdala processes their emotional charge. Research from the Walker Lab at UC Berkeley has found that REM sleep specifically strips the emotional tone from memories while preserving their informational content. A memory that felt distressing when encoded can feel neutral or resolved after a night of good REM sleep. This is not suppression. The memory remains, but the raw emotional reactivity attached to it is metabolized. What felt urgent at 10 at night may genuinely feel manageable at 7 in the morning. That is, sleep doing its work. The phenomenon of rumination, repetitive, intrusive thinking about problems or fears, is significantly amplified by sleep deprivation and significantly reduced by adequate rest. Research published in the journal Emotion found that just one night of poor sleep increased ruminative thinking by nearly 50% in healthy adults. The mechanism involves reduced activity in the lateral prefrontal cortex, which normally acts as an inhibitory check on the amygdala's alarm signals. Without this check, worry loops become self-sustaining. This is why the racing mind at 2 a.m. after poor sleep often becomes quiet after full rest. The quieting is not willpower. It is restored prefrontal inhibitory function. Sleep does not just rest the mind. It breaks cycles the mind could not break on its own. Self-compassion, the ability to treat one's own distress with kindness rather than judgment, has a measurable neurological substrate. Research by Kristin Neff at the University of Texas and by neuroscientists at the Max Planck Institute for Human Cognitive and Brain Sciences shows that self-compassionate states activate the care system in the brain. The same networks activated by compassion toward others, rather than the threat system. The threat system is most active when the brain is overstimulated and depleted. This means the capacity for self-compassion is directly related to the brain's resting state. A brain that is well rested and neurochemically replenished is a brain that can be kind to itself. Internal peace and self-compassion are not separate achievements. They arise together from the same conditions. The posterior cingulate cortex, a central hub of the default mode network, is one of the most metabolically active regions in the entire brain, consuming disproportionately more glucose than surrounding regions. Researchers believe this high metabolic demand reflects its continuous role in integrating autobiographical memory, social cognition, and present moment awareness into a coherent sense of self. When sleep-deprived or overstimulated, this region shows abnormal connectivity. The sense of self feels fragmented or unstable. After adequate rest, posterior cingulate connectivity normalizes, and with it comes the sense of being grounded and recognizably yourself. Internal peace is the brain successfully integrating its own history, and it does this best at night. The human stress response was designed for acute, time-limited threats. The cortisol and adrenaline it releases are meant to be burned off through physical activity, then followed by a recovery period. Modern life, however, generates chronic low-grade stress, social friction, financial uncertainty, information overload that activates the same response without resolution. The body remains in low-level activation, never fully completing the stress cycle. Researchers studying stress physiology, drawing on frameworks that remain the subject of ongoing scientific debate, have emphasized the importance of completing the cycle. Sleep, particularly the combination of deep slow-wave sleep and REM, appears to be one of the most reliable biological mechanisms for doing exactly that. Night is where the cycle, at last, finds its end. Melatonin, the hormone most associated with sleep onset, does more than signal bedtime. Recent research has identified melatonin receptors in areas of the brain associated with mood regulation, including the suprachiasmatic nucleus and the hippocampus. Melatonin appears to have direct anti-anxiety effects, possibly by modulating GABA receptor activity, the same receptor targeted by anti-anxiety medications. Studies have found that melatonin supplementation reduces pre-sleep anxiety in clinical populations, supporting the hypothesis that its natural rise at night serves a dual purpose, not just preparing the body for sleep, but lowering the emotional pitch at which the mind enters that sleep. The night itself is medicating you, gently, with your own chemistry. The transition from wakefulness to sleep, the hypnagogic state, is associated with a loosening of the brain's usual constraints on association and imagery. As theta waves increase and alpha waves give way to sleep spindles, the prefrontal inhibitory system begins to relax. Images become more fluid. Connections become less logical and more creative. And the sense of self becomes temporarily more porous. Many artists and scientists have reported accessing their most original insights in this liminal state. Edison was famously known to nap deliberately to capture hypnagogic imagery. This state is not confusion. It is the brain operating with reduced top-down control, allowing bottom-up associations to surface freely. The threshold of sleep is one of the most naturally creative moments in the day. Heart rate variability. The variation in time between consecutive heartbeats is one of the most sensitive physiological measures of psychological well-being. High heart rate variability indicates a nervous system that is flexible and capable of shifting fluidly between states of activation and rest. Low heart rate variability is associated with anxiety, depression, and impaired emotional regulation. Deep sleep consistently increases heart rate variability, and this increase persists into the following day, meaning the emotional resilience you carry through Tuesday morning was partly constructed by how fully you rested Monday night. Your nervous system's capacity to handle whatever the day brings is being calibrated right now by the quality of this night's stillness. The concept of neuroplasticity, the brain's capacity to reorganize itself by forming new neural connections, is not uniformly distributed across the day. Research from multiple sleep laboratories has found that synaptic plasticity is most active during sleep. The synaptic homeostasis hypothesis, developed by Giulio Tononi and Chiara Cirelli at the University of Wisconsin, proposes that sleep resets synaptic strength, potentiating useful connections made during the day while pruning those that are redundant. This is why what you learn the day before an exam consolidates overnight, and why poor sleep impairs new learning the following morning. You are not storing information while awake. You are re-encoding it while asleep. Internal peace is not, according to current psychological and neuroscientific evidence, a permanent state that some people possess and others lack. It is a recurring condition that the brain moves toward naturally, given adequate rest, quiet, and reduced threat. Every human brain, under the right biological conditions, organizes itself toward coherence, toward reduced internal conflict, and toward the integration of experience into a manageable narrative. The barriers to this state are largely external overstimulation, chronic stress, insufficient sleep, and the absence of genuine quiet. Tonight, by choosing to lie still and let the science carry you, you are removing those barriers. The brain knows what to do next. It has always known. You're still here with us. And that means everything. A gentle subscribe helps another sleepless mind find their way home. Let's take a breath together now. One sleepy soul at a time. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence, heart beating, lungs breathing, brain thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. Your arms feel heavy, your jaw is soft. Even your thoughts are beginning to slow, like leaves settling on still water. You are a complete ecosystem, diverse, self-balancing, and quietly extraordinary. Now we continue. The anterior cingulate cortex acts as the brain's conflict monitor, detecting when two competing responses are simultaneously active and signaling the need for resolution. In a resting, well-resourced brain, this region operates smoothly, allowing conflicts to be resolved with minimal distress. In a depleted brain, the anterior cingulate remains in heightened activation, generating inner conflict and a persistent unease nothing specific can account for. Sleep and stillness reliably reduce this hyperactivation. The sense that everything feels slightly wrong, without clear reason, often traces to this region operating under exhaustion. Rest quiets the conflict monitor. The wrongness, most nights, is simply the brain asking to be let go. The neurotransmitter serotonin plays a complex role in nighttime healing beyond its reputation as a mood stabilizer. During the day, serotonin is most active in circuits related to social behavior and motor control. At night, it becomes the primary precursor to melatonin, converted through the pineal gland, beginning the cascade that produces the hormonal environment of sleep. Serotonin also modulates the Raphe nuclei, the brainstem structures governing sleep stage transitions, including the gatekeeping of REM sleep, a brain that is serotoninergically well supported. Through adequate rest and reduced evening stimulation, moves through sleep architecture more smoothly. The quality of your peace tonight depends partly on the serotonin story of your entire day. Memory reconsolidation. The process by which stored memories are re-encoded with slight modifications each time they are recalled is most active during sleep. Research from New York University and the Weizmann Institute of Science has shown that disturbing memories retrieved during the day are rendered temporarily malleable before being restored overnight. During this window, the emotional intensity associated with the memory can diminish, and new contextual information can be incorporated. This is the neurological basis of why events feel less distressing after sleep. Your sleeping brain is not merely an archivist. It is a gentle editor, working every night on the narratives you carry. The orbitofrontal cortex, a prefrontal region involved in value-based decision-making and emotional learning, undergoes significant consolidation during slow-wave sleep. Research has found that activity in this region during the day predicts the content of subsequent slow-wave sleep oscillations, suggesting a direct relationship between emotional experiences and the brain's overnight processing agenda. The relationship conflicts, professional disappointments, and interpersonal confusions of the day are not simply set aside at bedtime. They are cued for neural review. The brain prioritizes emotionally significant material in overnight processing. This is not rumination. It is the brain doing the work it was designed to do with difficult experience. The night is a tribunal that tends toward forgiveness. Slow-wave sleep, the deep, dreamless stages characterized by high amplitude, low-frequency delta waves, has been specifically linked to the restoration of emotional resilience. A study published in Current Biology by Els van der Helm and Matthew Walker found that the neurochemical environment of slow-wave sleep, particularly the reduction in norepinephrine, allows the emotional brain to reprocess disturbing experiences without the amplifying effect of stress hormones. This is the neurological reason that sleep genuinely heals. The norepinephrine reduction during deep sleep creates a pharmacological window in which traumatic memories lose their neurochemical charge. Each deep sleep period is a small act of emotional medicine, available to you without prescription, every single night. The lateral habenula, a small nucleus in the diencephalon, is sometimes called the brain's disappointment center. It becomes active in response to unmet expectations and perceived failure, generating the withdrawal and low motivation that follow setbacks. Research from multiple institutions has found that during REM sleep, the lateral habenula shows reduced metabolic activity, suggesting that REM may serve in part to reset this disappointment circuit. Sleep deprivation leaves it in chronic hyperactivation, which maps closely to the clinical presentation of depression. The emotional heaviness of persistent low mood is not merely psychological. It is a failing circuit, asking for the sleep that would repair it. Interoceptive awareness, the brain's ability to sense and interpret internal bodily signals, is significantly impaired by sleep loss. Research from the University of California, Berkeley found that sleep-deprived individuals show reduced ability to accurately read their own emotional states and a degraded capacity to distinguish between physical sensations and emotional feelings. This degradation of self-knowledge has downstream consequences for decision-making and self-regulation. You are less accurately yourself when under-rested. The version of you that feels certain of things you would normally question is not your authentic response. It is your depleted nervous system misreading its own signals. Sleep restores the accuracy of the self's internal reporting. The thalamus plays a special role in the transition to sleep by actively suppressing sensory input. As you move towards sleep, the thalamus begins generating sleep spindles, bursts of rhythmic neural activity that serve as a sensory gate, blocking external signals from reaching the cortex. This gating function is not passive. It requires active neurological work. Sleep spindles are most prominent in stage 2 sleep, and their density has been correlated with cognitive performance and memory consolidation. The brain, at the threshold of rest, is building a wall between you and the world, not to shut you out, but to give you the interior access that the world, while it is present, always interrupts. The concept of psychological safety, developed by Amy Edmondson at Harvard Business School, has a direct neurological correlate. Environments perceived as safe reduce amygdala activation and increase prefrontal limbic connectivity, allowing higher-order processing to take precedence over reactive self-protection. Your bedroom, when associated with consistent rest and security, generates this same neural profile, the familiar sensory cues of your sleeping environment, the weight of your blanket, the ambient temperature, the particular darkness, activates safety networks through conditioned association. This is why sleep hygiene matters beyond habit. It is literally programming the brain's threat detection systems to downregulate at the cue of lying down. Research in affective neuroscience finds that the capacity for positive emotion is not simply the presence of pleasure. It is the brain's ability to return to a resting baseline after both positive and negative events. This capacity, sometimes called emotional resilience, is directly tied to prefrontal cortex function and is one of the most sleep-sensitive aspects of psychological well-being. Individuals who regularly obtain sufficient sleep show faster return to emotional baseline after stressors and more sustained access to positive affect, not because they are more fortunate, but because their recovery circuits are more fully restored. The difference between a day that feels manageable and one that feels relentless is, more often than not, the night that preceded it. The brain contains a network of mirror neurons, cells that activate both when you perform an action and when you observe another performing it, that underlie the human capacity for empathy and social understanding. Research from Giacomo Rizzolatti's lab at the University of Parma, where mirror neurons were originally identified in macaque monkeys, has led to extensive human neuroimaging studies suggesting analogous systems in the human brain. These circuits are measurably impaired by sleep loss. Sleep-deprived individuals show reduced empathic accuracy and a tendency to interpret neutral social signals as threatening. Rest does not just restore you, it restores your ability to understand and feel for others. Non-declarative memory, responsible for skills, habits, and emotional conditioning, is consolidated during sleep through mechanisms distinct from those governing declarative memory. Procedural skills, émotionnelle association, and implicit behavioral patterns are all refined and stabilized overnight. The emotional habits you are trying to build, self-compassion, equanimity, patience, acceptance, are being consolidated during sleep each night. You practice them during the day. The nervous system is not just storing what you did, it is strengthening what you are becoming. Each night of rest is an investment in the person who will wake up tomorrow. The suprachiasmatic nucleus, a small paired structure in the hypothalamus containing roughly 20,000 neurons, governs the master circadian clock that coordinates virtually every biological process in the body. Light entering the retina calibrates this clock each morning, and its downstream hormonal signals regulate the precise timing of repair, immune function, and neural consolidation throughout the day. Disruption of circadian rhythm. through irregular sleep schedules or light exposure at night, has been linked to increased risk of mood disorders and impaired cognitive function. The internal peace you are seeking tonight is, in part, a circadian phenomenon. The night is scheduled to be healing. The clock has been running toward this moment all day. The release of human growth hormone, one of the body's primary tissue repair agents, occurs in a single large pulse during the first cycle of slow-wave sleep, typically within 90 minutes of sleep onset. This pulse does not repeat with equal magnitude in subsequent cycles. The first deep sleep of the night is uniquely restorative, and delayed sleep onset meaningfully reduces this repair event. The body's most important maintenance window is early in the night. This is not pressure to sleep immediately. Pressure is counterproductive, but a reason to create conditions that allow sleep to begin naturally. Dim the light. Quiet the phone. The repair crew is waiting. Across cultures and throughout history, night has been understood as a space of protection, inwardness, and access to self. Indigenous traditions worldwide designate the night as the time for dreaming, for receiving, for the kinds of knowing that the day's noise cannot allow. Modern neuroscience is now articulating, in molecular and electrochemical language, what these traditions have long understood in symbol and ritual, that the darkness is not empty, but full. Not a cessation of life, but a different kind of life, oriented entirely inward. The science and the ancient knowing converge on the same message: you are not disappearing into the night. You are going somewhere the daylight cannot follow. You're still here with me, thoughts still flickering like candlelight. Just notice. Don't judge. Just notice where your mind is. We're exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. The vagus nerve, the primary conduit of the parasympathetic nervous system, carries signals in both directions between the brain and body. Roughly 80% of vagal fibers travel from the body to the brain, meaning the body is continuously informing the brain of its physiological state. This explains why the physical act of lying still, breathing slowly, and releasing muscular tension does not merely accompany psychological relaxation. It produces it. The body's resting signals, transmitted upward through the vagus nerve, directly alter the brain's affective state. Slow breathing activates vagal afferents that reduce amygdala reactivity within minutes. You do not need to think your way to calm. Your body can lead you there. Psychological researchers distinguish between passive rest, reduced external stimulation without directed internal activity, and restorative rest, a shift in neural organization toward integration and self-referential processing. Screen exposure at night typically produces passive rest at best. True restorative rest requires the near-total absence of external demands. This is not a judgment of modern habits, but a statement of neural architecture, the default mode network. With its consolidating and peace-generating functions, simply cannot activate fully while the eyes and ears are receiving content. The phone off, the screen dark, the room quiet. These are not deprivations. They are permissions. The temporal parietal junction. At the intersection of the temporal and parietal lobes is involved in perspective taking, social cognition, and the subjective sense of being a distinct self embedded in a larger world. During meditation and deep relaxation, activity in this region shifts in ways that temporarily soften the perceived boundary between self and environment. Practitioners describe this as a sense of expansion, of belonging to something larger. Neuroimaging studies of long-term meditators show structural thickening in this region, consistent with repeated activation. You do not need a meditation practice to access a version of this state. You need what you already have: a quiet room, a still body, and a night without demands. The experience of awe, perceiving something vast and self-transcending, has been found in research by Dr. Keltner and colleagues at UC Berkeley to produce measurable reductions in inflammatory markers and improvements in well-being. Critically, awe appears to activate the default mode network while simultaneously reducing activity in the self-referential centers associated with self-focused anxiety. The practical implication: awe quiets the small, worried version of the self through a different mechanism than relaxation does. Not by calming the threat system, but by expanding the sense of self beyond it. The facts about your own brain that you are traveling through tonight are not merely interesting. They are an invitation into precisely this kind of self-transcending wonder. The quality of the internal monologue, the continuous stream of self-directed thought, is profoundly shaped by the brain's resting state. Research by Ethan Kross at the University of Michigan has shown that self-talk under conditions of psychological threat becomes more self-critical and more stuck in narrow loops. Under conditions of safety and rest, the same internal voice becomes more flexible, more compassionate, more capable of generating helpful perspective. The voice you hear in your head is not a fixed feature of your personality. It is a product of your nervous system's current state. The harshest self-critic in the room often turns out to be an exhausted brain that has not yet been given the chance to rest. Stage 2, sleep, which accounts for roughly half of total sleep time in healthy adults, is characterized by K-complexes, large amplitude waveforms that appear to serve as a response to environmental disturbance, suppressing arousal and protecting sleep continuity. K-complexes have been found to correlate with fluid intelligence and processing speed, and their disruption by noise or light is associated with reduced cognitive performance the following day. The brain in stage 2 is actively defending its own restoration, generating the mechanisms needed to stay in rest, despite the world's continued existence outside. Your ability to sleep is not passive surrender. It is the brain mounting an active biological defense of its own right to heal. The hypothalamic pituitary adrenal axis, the hormonal cascade governing the stress response, follows a precise circadian rhythm. Cortisol begins rising in the early morning, peaking shortly after waking, then declining through the day to its overnight nadir. The overnight cortisol low creates a permissive hormonal environment for immune function, tissue repair, and emotional processing. Disruption of this rhythm through chronic stress, irregular sleep, or cortisol elevating behaviors in the evening compresses the nightly low, reducing the window available for repair. What you do in the last 2 hours before sleep is not just preparation for rest, it is the physiological framing of the night itself. The concept of sleep pressure, the homeostatic drive towards sleep that builds during wakefulness through adenosine accumulation, operates in parallel with circadian rhythm. These two systems converge at the optimal sleep window when you feel the heavy, drowsy pull of sleep at night. You are feeling the convergence of adenosine and the circadian signal from the suprachiasmatic nucleus, two independent biological systems arriving at the same conclusion simultaneously. The body's wisdom in this moment is not ambiguous. It is a unison call from systems that have been preparing for hours. The heaviness you feel is not weakness. It is the body becoming eloquent in the only language biology speaks: sensation. The prefrontal cortex's capacity for cognitive reappraisal, reinterpreting the meaning of a stressor to reduce its emotional impact, is one of the most effective tools for emotional regulation available to the human brain. Research by James Gross at Stanford has demonstrated that reappraisal, unlike emotional suppression, reduces both subjective distress and physiological arousal simultaneously. But this capacity is among the first to degrade under sleep deprivation. A rested prefrontal cortex can generate genuine alternative interpretations of difficult situations. A depleted one defaults to the most emotionally reactive interpretation available. The difference between seeing a setback as information and seeing it as confirmation of your worst fears is, in large part, a sleep story. Halfway through our journey, the answer to the central question, why your mind heals best in total stillness at night, has moved from abstract neuroscience to embodied reality. You have traveled through the default mode network, the glymphatic system, REM's emotional repair, slow-wave sleep's neurochemical medicine, the circadian biology of cortisol and growth hormone, and the vagus nerve's upward conversation with the brain. The stillness you are in right now is not waiting for healing to begin. It is healing. Your brain is doing, in this precise moment, exactly what all 100 facts have been describing. The science and the experience are not separate. They are the same thing, arriving from two directions. And imagine, even when everything seems empty, the space inside and around you is never truly still. There are waves, vibration, invisible energy in every quiet room. Imagine you're floating on a calm lake, but beneath the surface, there is always a gentle current, warmth rising through the water, a slow and steady pulse you did not create and do not need to maintain. The space inside your body is like that. Your cells are exchanging. Your breath is cycling. Your brain is organizing, all without effort from you. You are not responsible for keeping yourself alive tonight. The body already knows what to do. Now we continue the journey. The neuroscience of self-compassion reveals something counterintuitive. Turning kindness toward yourself is not self-indulgence, but self-repair. Research from Kristin Neff and Christopher Germer shows that self-compassion activates the brain's caregiving networks, reducing cortisol and increasing oxytocin release. Oxytocin has receptors throughout the limbic system and appears to modulate amygdala reactivity directly. The act of treating your own distress gently, rather than criticizing or suppressing it, is a neurochemical intervention. The brain cannot clearly distinguish between kindness received from another and kindness generated internally. Your own gentleness toward yourself is, biologically, as real as anyone else's. Sleep architecture. The pattern of N1, N0 high, slow wave, and REM sleep is not uniform. Early cycles are weighted towards slow wave sleep, supporting physical and neural repair. Later cycles shift toward REM, with the longest REM periods in the final hours before waking. Shortening sleep from 8 hours to 6 disproportionately truncates REM. Since REM is most associated with emotional memory processing and creative insight, the person who consistently sleeps 6 hours instead of 8 loses the most psychologically meaningful portion of the night. The last 2 hours are not overtime. They are the most important shift. Neurogenesis, the formation of new neurons in the adult brain, remains an area of active scientific debate, particularly regarding the hippocampus. Early rodent studies showed robust adult hippocampal neurogenesis, and initial human studies supported the finding, but subsequent research has yielded conflicting results. Current consensus holds that some degree likely occurs in humans, at rates considerably lower than in rodents, and that sleep appears to support it while chronic stress suppresses it. This finding should be understood as promising but preliminary. What is not debated is that sleep supports synaptic plasticity and neural repair through multiple well-established mechanisms. The sleeping brain is actively building the architecture of mind. The role of the cerebellum in emotional processing has been one of the more unexpected discoveries of recent neuroscience. Long understood primarily as a motor control center, the cerebellum is now recognized as containing circuits involved in emotional learning and the timing of emotional responses. Research published in Science in 2019 identified direct cerebellar projections to the brain's primary dopamine reward center, suggesting a previously unknown cerebellar role in reward and motivation. Sleep is required for cerebellar consolidation, the coordination of your emotional responses, not just what you feel, but how smoothly and appropriately you feel it, is being calibrated in the cerebellum every night. The experience of meaning, the sense that one's experiences have significance beyond the moment, has been linked by positive psychology researchers to activation of cortical midline structures, particularly the medial prefrontal cortex. These structures are central nodes of the default mode network. This is not coincidence. The DMN's core function, integrating autobiographical memory, social experience, and present moment awareness, is precisely the neural substrate of meaning-making. The sense that your life has shape and direction is constructed and maintained by the same network that activates when you lie still in the dark. Every night of genuine rest is, neurologically, an act of meaning, maintenance. The body keeps a running account of psychological stress at the cellular level, in the form of inflammation. Chronic stress consistently elevates markers of systemic inflammation through complex pathways involving the hypothalamic pituitary adrenal axis and the sympathetic nervous system. Sleep is one of the most effective anti-inflammatory interventions available. Multiple large-scale studies have found that short sleep duration and poor sleep quality are independently associated with elevated inflammatory markers, and that sleep extension in chronically sleep-restricted individuals measurably reduces them. The body's inflammatory response to the stress your mind has carried today can be metabolized tonight. Not completely, not in one night, but incrementally. Psychological flexibility, the capacity to be present with difficult thoughts and feelings without avoiding them or being dominated by them, is associated with increased prefrontal limbic connectivity. Sleep appears to support psychological flexibility by restoring prefrontal function, completing emotional processing cycles during REM, and reducing the amygdala hyperreactivity that drives avoidance. The person you are, after a full night of rest, is not just less tired. They are more capable of being with what is difficult without flinching away. Rest is a practice of psychological courage. Thermal regulation plays an underappreciated role in sleep onset and quality. Core body temperature begins to fall in the early evening, driven by heat redistribution to the extremities, causing the hands and feet to warm while the torso cools. A cool sleeping environment, typically between 60 and 67 degrees Fahrenheit, supports this natural temperature drop, while an overly warm room interferes with it. The body's journey into sleep is partly a thermal journey, a deliberate cooling that creates the conditions for deep rest. The temperature of your room, the weight of what covers you. These are not small things. They are the body's climate for healing. The neuroscience of trust, the neural basis of feeling safe within one's own life, involves the integration of oxytocin signaling, prefrontal evaluation, and amygdala gating. Persistent distrust keeps the amygdala in a state of chronic vigilance that is biologically incompatible with restorative sleep. Research on attachment theory consistently finds that individuals with secure attachment, those who fundamentally trust that they are safe and cared for, show better sleep quality and more time in restorative sleep stages. The neural conditions for trust and for deep sleep are almost identical. They require the same fundamental signal: it is safe to let go. The experience of gratitude, studied extensively by Robert Emmons at the University of California, Davis, has been found to improve sleep quality in multiple randomized controlled trials. Participants who wrote brief gratitude journals before bed fell asleep faster, slept longer, and reported better morning mood. Neurologically, gratitude activates the medial prefrontal cortex while reducing activity in the anterior insular cortex, which is associated with threat processing. Gratitude shifts the brain's orientation from scanning for what is wrong to recognizing what is present and sufficient. The mind that finds, before sleep, one thing that is genuinely good, has already begun its own healing. Adenosine, the sleep pressure molecule that accumulates during wakefulness, does not merely make you feel tired. It actively modulates neural activity by binding to adenosine receptors throughout the brain, reducing excitatory transmission. This is why caffeine, which blocks adenosine receptors, promotes wakefulness. When adenosine is allowed to do its work unimpeded, it creates a state of gentle, distributed neural quieting that is the biological substrate of drowsiness. The heavy, soft, yielding sensation of genuine sleepiness is adenosine speaking, the brain's own chemistry, acknowledging that the day's work is done and the night's work is ready to begin. You are not fighting adenosine. You are following it home. Research in social neuroscience has found that loneliness, the subjective experience of social disconnection, activates the same pain circuits as physical pain. Lonely individuals show increased amygdala reactivity, reduced sleep quality, more fragmented sleep architecture, and elevated inflammatory markers. Notably, it is the subjective experience of disconnection, not the objective number of social contacts, that drives these effects. Feeling connected to the people in your life, to this voice, to the larger community of minds traveling through the same quiet, reduces the neural cost of the night. You are not alone in this stillness. The process of extinction learning, by which the emotional charge of a conditioned fear response is reduced through repeated, non-reinforced exposure, is strongly dependent on sleep. Research from the Sleep and Memory Lab at Harvard Medical School has found that extinction learning acquired during the day is consolidated primarily during REM sleep that night. When individuals are sleep-deprived after extinction training, the learned fear response returns more strongly the following day. Sleep appears to be a necessary biological component of the brain's ability to learn at a deep level that something once frightening is now safe. Healing of every kind works better with sleep. The neural circuitry of hope, the anticipation of positive future outcomes, is centered in the prefrontal cortex and the nucleus accumbens, the brain's primary reward anticipation hub. Sleep deprivation reliably disrupts this circuit, reducing dopamine receptor sensitivity and impairing the brain's ability to generate and sustain hopeful future projection. Chronic sleep restriction is associated with pessimism and diminished motivation, not because circumstances have worsened, but because the neural architecture of hope is running on insufficient resources. Tonight, rest is not escape from difficulty. It is maintenance of the biological capacity to face it tomorrow with something resembling hope. We now understand that internal peace is not a destination the mind arrives at through effort. It is a condition the body creates through rest, and the mind inhabits by permission. Every neurological system discussed tonight, the default mode network, the glymphatic system, the vagal regulation, the cortisol cycle, the sleep spindles defending rest, the REM memory reprocessing, all are working toward the same end, bringing the organism back to functional coherence, to integration, to readiness. What you call peace is the system working as it was designed. The night is not a passive pause. It is the active, biological heart of healing. The thalamocortical system, the bidirectional communication network between the thalamus and the cortex, plays a central role in consciousness, attention, and the regulation of sleep. During the transition to sleep, this system shifts from the desynchronized activity of waking to the synchronized oscillations of sleep. Slow oscillations, sleep spindles, and delta waves. Disruption of this synchronization can cause sleep fragmentation even without fully waking the sleeper. The experience of waking unrefreshed, despite adequate hours in bed, often traces to this disruption. Deep rest is not just the absence of waking, it is the presence of a specific organized neural state the brain must successfully construct. The role of narrative in psychological healing has been studied extensively by James Pennebaker at the University of Texas, whose research on expressive writing found that brief periods of writing about difficult experiences produced measurable improvements in immune function and psychological well-being. The mechanism involves constructing a coherent narrative around previously unprocessed experience, the default mode network, active during nighttime rest and dreaming, performs an analogous function. It reviews, reorganizes, and constructs coherent narratives around the day's experiences. Lying quietly in the dark, allowing the mind to wander and review, is neurologically similar to what expressive writing accomplishes on paper. Emotional granularity, the ability to differentiate between distinct emotional states rather than experiencing all negative states as simply feeling bad, is associated with better emotional regulation and improved psychological well-being. Research by Lisa Feldman Barrett at Northeastern University links high emotional granularity to greater interoceptive awareness and stronger prefrontal limbic connectivity. Sleep supports emotional granularity through its restoration of both prefrontal function and interoceptive accuracy. A rested brain can tell the difference between loneliness and sadness, between anxiety and excitement. A depleted brain flattens these distinctions into a single, undifferentiated weight. The science of positive neuroplasticity, intentionally cultivating mental habits that strengthen adaptive neural circuits, rests on the principle that what the brain does repeatedly becomes what the brain does easily. Researcher Rick Hansen has written about the brain's negativity bias, encoding threatening experiences more efficiently than positive ones. Positive experiences, to have the same neuroplastic impact, benefit from deliberate attention and consolidation during sleep. The equanimity, patience, and capacity for wonder that you practice during the day is being wired more permanently into your neural architecture tonight. Every positive experience you carried into sleep is an investment in the structure of tomorrow's mind. Research into the neuroscience of mindfulness has found that regular practice produces measurable structural changes in the brain, including increased cortical thickness in the prefrontal cortex and insula, and reduced amygdala volume. A study from Harvard Medical School found that after an 8-week mindfulness program, the quality of participants' sleep was one of the strongest predictors of how much amygdala change had occurred. Sleep appears to be necessary for the consolidation of the neuroplastic changes that mindfulness practice initiates. If you have ever meditated, practiced mindfulness, or simply tried to be kinder to yourself, that work is being built into your brain tonight. While you sleep, the phenomenon known as spontaneous insight, the sudden resolution of a problem worked on without success, occurs disproportionately during REM sleep and the hypnagogic state just before sleep onset. Researchers suggest that REM allows weak, non-obvious associations between distant pieces of knowledge to surface. Associations that focused, waking thought tends to suppress. The examples are numerous. Kekule's dream of the snake eating its tail, Loewy's experimental design arriving in a dream and leading to his Nobel Prize. The sleeping mind does not merely process what the waking mind provides. It generates what the waking mind could not find. The anterior insula, involved in interoception, emotional awareness, and empathy, shows characteristic activity patterns during states of genuine compassion that distinguish them from mere sympathy or pity. Compassion activates approach-oriented circuits. Sympathy tends to activate withdrawal or distress circuits. Research from Tanya Singer at the Max Planck Institute has found that compassion training reduces compassion fatigue and increases neural resilience. Sleep supports the insula's capacity for this kind of compassionate awareness. The caregiver who is also well rested is a better caregiver, not because they care more, but because the neural circuits that translate caring into effective action are functioning as they were designed. The brain's capacity for forgiveness, releasing resentment toward oneself or others, has been linked in neuroimaging research to decreased activity in the lateral prefrontal cortex and increased activity in the ventromedial prefrontal cortex, associated with value integration and self-transcendence. Forgiveness neurologically requires the prefrontal cortex to override the amygdala's cataloging of threat and harm, a function that is profoundly sleep-sensitive. Sleep-deprived individuals show reduced capacity for perspective-taking and a stronger tendency to remain fixed in hurt or anger. Some of what we hold against the world is only a tired brain's inability to let go. Research on the neurobiology of awe has found that these states produce a characteristic EEG signature, increased alpha and theta power, reduced beta, remarkably similar to the brain states observed during deep meditation and the transition to sleep. While earlier research linked awe to reduced inflammatory markers, this sleep-adjacent finding offers a distinct and complementary insight. Awe may support sleep not just through its anti-inflammatory effects, but through its direct overlap with the neural signature of rest itself. A mind that has genuinely experienced awe today carries something towards sleep that resembles the state sleep itself is trying to reach. Internal peace is not a reward for the sufficiently disciplined mind. It is a biological gift the human brain extends to itself under the right conditions. Those conditions are not exotic or demanding. They are sufficient darkness, sufficient quiet, sufficient safety, and time. The default mode network integrates. The glymphatic system clears. REM metabolizes the day's emotional residue. Slow-wave sleep replenishes what cortisol depleted. The vagus nerve settles the body's alarm into rest. And in the quiet created by all of this, something the day could never quite offer finally arrives. The sense of returning to yourself, simply yourself, a whole, intact, and at rest. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your breath. Inhale. Exhale. Inhale. Exhale. A small cycle within a vast universe of cycling things. The body repairs in cycles. The brain consolidates in cycles. Emotions move through activation and rest, through tension and release, through question and quiet resolution. You are also part of that eternal movement. You don't need to hold on to anything tonight. Let everything unfold in its perfect order, like thoughts settling through still water, unhurried, unresisting, simply existing. We're almost there now. Sleep is the only state in which the brain simultaneously consolidates memory, clears metabolic waste, regulates emotion, repairs synaptic connections, and resets the hormonal environment for the following day. No waking state, however restful, accomplishes this combination. This is why sleep cannot be fully compensated for by rest alone. What happens in the dark, while you are absent from yourself, is irreplaceable. The bedtime stories humans have told across cultures, myths, fables, lullabies, almost universally, contain a structural arc from danger to safety, from separation to reunion, from confusion to resolution. This may not be accidental. The narrative arc of safety is also the neurological arc of sleep onset, a journey the mind makes from vigilance to trust. The stories we give to children at night are teaching them a template the brain will use for a lifetime. Your brain consumes approximately 20% of the body's total energy at rest. Despite comprising only 2% of body weight, during sleep, the metabolic demands of the cortex decrease, allowing energy to be redirected toward repair, immune function, and the glymphatic clearance process. The sleeping brain is not a low-power state. It is a different allocation of the same extraordinary resource, the experience of waking from deep, restorative sleep into a state of genuine peace. Before the day's concerns return, is neurologically distinct from ordinary waking. It involves a brief window of heightened default mode activity and reduced prefrontal filtering, during which the integrated perspective of the night's processing is still available. The peace of a good morning is not simply the absence of tiredness. It is the harvest of the night's work, briefly and beautifully legible. The capacity for self-awareness, the brain's ability to observe its own processes, depends on the coordinated activity of the medial prefrontal cortex, the posterior cingulate cortex, and the anterior insula. These regions form the core of the default mode network. Self-awareness is not a constant. It is a function the brain performs more or less accurately, depending on the state of its underlying infrastructure. Rest is not merely good for the self. It is constitutive of the self's ability to know itself. Nighttime is when the immune system conducts its most intensive surveillance. Natural killer cells show peak activity during the early hours of sleep. Interleukin-2, a cytokine critical for immune activation, is produced primarily during slow-wave sleep. The immune system and the sleep system have co-evolved, sharing regulatory signals and mutual dependencies. The night does not just heal the mind, it heals the body that carries it. Research on emotional labor, managing one's emotional expression in social and professional contexts, has found that it draws on the same prefrontal resources as other forms of self-regulation. Individuals who have spent the day managing how they appear to others carry a particular form of depletion by evening. The privacy of night, the release from the requirement to present oneself to the world, has a neurologically restorative quality that goes beyond quiet. It is the relief of the performed self finally being allowed to rest. Lullabies, with their characteristic descending melodic lines, slow tempos, and repetitive structures, appear to engage the brain's auditory and limbic networks in ways that specifically reduce amygdala reactivity. The pattern is present across cultures. Humans everywhere have understood that certain sounds guide the frightened and the tired toward rest. The voice you are hearing now is one descendant of that ancient tradition. The same impulse in scientific language. In the particular darkness of this night, the phenomenon of stress inoculation, by which manageable stressors, resolved successfully, build neural resilience to future stresses, requires sleep for consolidation. Research suggests that the hippocampal neuroplastic changes that underlie stress resilience are laid down during sleep following the stressful experience. The difficulties you navigate during the day are not simply endured. They are, given adequate sleep, converted into a more resilient neural structure. You are, slowly and biologically, becoming someone better equipped to be well. The feeling of homesickness, the ache for a place of safety, activates neural circuits that overlap with the circuits of physical pain. Research has found that images of home and familiar environments reduce amygdala reactivity and increase ventral striatum activity. The bedroom, when it has been consistently a place of safety and rest, becomes a neurologically encoded home within the home. The specific darkness of your room tonight, the particular quality of the silence, these are the sensory language of your own safety. Research has found that vividly imagined positive future outcomes activate the same anticipatory neural circuits as actual anticipated events. The brain does not fully distinguish between a richly imagined safe future and one that is objectively certain. The neurological response to hope is real, regardless of certainty. This is the biological mechanism of hope. The mind traveling through a night of quiet science, arriving gently at the edges of sleep, is practicing the act of imagining rest and peace. And the brain takes that practice seriously. The subjective experience of time distorts during the transition to sleep. The hypnagogic state is associated with a loosening of temporal binding, the brain's mechanism for ordering events into a coherent before and after sequence. Moments expand. The usual urgency of clock time diminishes. Researchers have found this temporal loosening correlates with reduced prefrontal beta activity and increased limbic theta. The distortion is not disorientation. It is the body beginning to release the relentless sequencing of what next into something closer to simply being, suspended, in a present that neither rushes nor ends. See tactile afferents, a specialized class of nerve fibers found in hairy skin, respond to light, slow-velocity touch, sending signals to the insular cortex and producing a reduction in heart rate and cortisol. These fibers appear to have evolved to process social touch, the gentle contact of caregiving and belonging, the weight of bedding against your skin, the warmth of your own body heat, These inputs reach C-tactile afferents and produce, measurably, the physiological signature of comfort. The body, even alone, knows how to be held. Acceptance, allowing present experience to be as it is, describes a neural state involving prefrontal regulation of the amygdala that is permissive rather than suppressive. Research has found that acceptance, unlike avoidance or suppression, reduces the secondary suffering that amplifies primary pain. Sleep, when approached with acceptance rather than demand, comes more easily. The night that is allowed to be whatever it is, restful or wakeful, dreaming or still, offers more than the night that is commanded to perform rest on schedule. Chronobiologists have found that even brief light exposure at night, particularly in the blue wavelength range emitted by screens, suppresses melatonin production and delays sleep onset. Conversely, genuine darkness creates the hormonal conditions for optimal sleep architecture. Research from Harvard's Division of Sleep Medicine has found that sleeping in darkness versus low-level artificial light is associated with reduced cardiovascular risk, better metabolic regulation, and improved mood. The darkness you have chosen tonight is not absence. It is an active biological ingredient in your healing. The body's temperature rhythm, declining through the evening, is linked to the consolidation of episodic memories, the emotional memories of specific personal experiences. Research from the University of Tübingen found that the neural replay of episodic memories during slow-wave sleep is correlated with the preceding evening temperature decline. The cooling body signals to the memory system that the day's experiences are ready to be filed. The conversations, the moments of beauty or difficulty you had today, are being integrated into your personal history tonight. Research on post-traumatic growth consistently identifies sleep quality as one of the strongest predictors of whether difficult experience leads to growth or prolonged impairment. Research by Lawrence Calhoun and Richard Tedeschi suggests that the narrative reconstruction of trauma requires the neural resources that only adequate rest provides. Growth, neurologically, is a slow-wave and REM sleep project. The difficult things you have lived through are not simply behind you. Given sleep, they are being composed, night by night, into something that may eventually carry meaning. The science of attention identifies the default mode as the source of mind wandering, and the task-positive network as the source of directed attention. Both networks are necessary. Research from Harvard University by Matthew Killingsworth and Daniel Gilbert found that mind-wandering accounts for nearly half of waking mental life, but mind-wandering during rest, the unfettered associative drift of a mind in no particular place, is neurologically productive rather than depleting. The wandering mind of nighttime rest is the default mode network doing the integrative work that focused attention cannot. Research on the neuroscience of patience, the capacity to tolerate delay and uncertainty, locates it primarily in the lateral prefrontal cortex and the anterior cingulate cortex, which together regulate impulsive responding and maintain goal-directed behavior across time. Sleep-deprived individuals show increased impulsivity and reduced tolerance for delay. The capacity to wait, to allow things to unfold, to trust that the incomplete will eventually complete, These are neurological capacities that the sleeping brain restores every night. Tonight, you are replenishing the biology of patience. The neuroscience of beauty involves the orbitofrontal cortex, the ventral striatum, and medial prefrontal regions associated with reward and self-referential processing. Research from Semir Zeki at University College London has found that beauty produces a characteristic prefrontal activation distinct from mere pleasure or interest. It involves a temporary expansion of the self outward toward the perceived object, the neurological opposite of rumination. Any of these facts, considered carefully, can be that doorway, and this state, once entered, reliably quiets whatever the day left behind. The final phase of sleep, the last REM period before waking, is associated with dreams characterized by greater narrative complexity, stronger emotional tone, and more frequent incorporation of recent personal experiences. Research suggests these late REM dreams weave recent experience into the longer narrative threads of autobiographical memory. The dreams you remember from the end of the night are the brain's final editorial pass, a last review of what matters, what connects, what belongs in the story of who you are. Waking gently, without alarm, after sufficient sleep, produces a characteristic neural state adenosine clearing, prefrontal activity normalizing, full cognitive function returning. In this state, there is a brief window of elevated default mode activity during which creative, integrative, and self-compassionate thought is particularly accessible. Many people describe their best ideas, their most accepting perspectives. Arriving in this window, you will not remember most of what tonight's sleep does for you, but you will feel it in the morning, in ways that feel like your own. The neurological foundation of peace turns out to be remarkably simple. The brain, given darkness and quiet and time, moves naturally toward coherence. It does this not because you earned it, but because coherence is what the brain is, at its biological core, always trying to achieve. Every night of genuine rest is the brain succeeding at what it was designed to do. What you feel when you wake restored is not reward. It is recognition, the recognition of yourself, returned from the night's long work, intact. The science of sleep describes not a passive vulnerability, but an active, orchestrated, biologically intelligent state. The thalamus builds its sensory gate. The hippocampus replays the day. REM strips emotional charge from memory. The glymphatic system clears cellular spaces. Growth hormone pulses into tissue. The default mode network integrates the narrative of the self. Every system is participating, contributing to the same project. The sleeping person is not absent. They are more fully engaged in the work of being alive than at almost any other moment. The real question this night has been answering is why you came here, to this quiet, to this voice, to the unfolding of science in the dark. The brain that sought this out was already practicing something the science describes the turn inward, the willingness to be still, the permission extended to the exhausted self. Internal peace is not achieved by understanding it. It is achieved by doing exactly this, choosing the quiet choosing the dark, letting the night do what it has always known how to do. And so, our quiet journey through the healing mind comes to a gentle close. We've traveled from the first silence that switches on the default mode network to the deep, slow-wave sleep that clears the mind's metabolic debris, discovering along the way that internal peace is not something you must earn, but something your brain returns to, given the conditions it has been asking for all along. From the chemistry of REM's emotional repair to the vagal pathways that settle the body's alarms into rest, we've glimpsed how the mind is both endlessly intricate and, at its deepest level, organized entirely toward wholeness. Internal peace reminds us that the mind's most essential work happens in silence, in the dark, in the spaces between demands. The brain reveals a patience, not the patience you practice, but the patience it is, working through the night on your behalf. Without this quiet, the healing queues indefinitely. By pausing to allow it, we make space for what the science has always known was waiting. In these final minutes, take the deepest breath you can, as deep as possible. Think about consciousness itself. Yours, mine, everyone listening, all awareness everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep. No boundaries left, only peace. Perhaps this thoughtful exploration of the healing mind brought you relaxation, rest, or quiet curiosity tonight. A gentle like and subscribe helps other sleepless souls discover this peaceful space too. It only takes a moment, but it means the world to us. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, farther than most journeys take you. You can allow these thoughts of internal peace to fade now, like candlelight dimming gently at the end of an evening, leaving only the warm, residual calm behind. Let your breathing deepen. Let your body feel heavier, as if the earth itself has decided to hold you a little more firmly tonight. If sleep comes, let it carry you, smoothly, inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the default mode network will still be there. The quiet intelligence of sleep will still be working. But tonight belongs to stillness. Rest well, quiet one, and remember, your brain has been on your side all along. Every night, it offers you the chance to come home to yourself. Fall asleep to gentle facts. Where science meets sleep, dream deeper with bedtime science. Good night.